Okay, so first thing that comes to mind, everybody, that you should definitely want to go through in your head. Um, you know, what's the difference between molality and molarity? Okay. So if you don't know the difference, this is where you're going to get caught up. Okay, because it's asking for molarity, and then you're like, well, I thought molality was the same thing. No, it's not. Do you need help in chemistry? Well, get ready to play your favorite game show. This game show is meant to help you, yes, you understand chemistry. Here's the game show. There's 3 questions. If you get all 3 right, we call you a brave scholar. If you get 2 right, you are a never scared student. So you kind of know yourself, or you know majority of it. If you get 1 right, well, y'all remember that show, Courage the Cowardly Dog? Well, that's you. You're kind of brave, but you're acting scary the entire time. Get to know your stuff. And if you don't get any right, well,
you have some explaining to do.
I'm your host, Dr. J, and let's play What Do You Know? A solution is made using 65 grams of hexane, and the molar mass of hexane is 86.18 grams per mole. You also have 60 grams of octane, the molar mass being 114.2 grams a mole, right, grams per mole. What's the mole fraction of the hexane in the solution? Mole fraction. What exactly is mole fraction? You have your moles of hexane on top, and then what do you have on bottom, right? With the fraction, you know, you got your whole solution. So in this case, I got moles of hexane, and I have, let me make that line longer, moles of octane. Okay, so this is what my equation is going to be. Now, what are we missing here? So let's convert. 65.1 grams of hexane. I'm just gonna put a hex, not like a hex on you. What's that thing? I put a spell on you. Y'all know what I'm talking about. Shout out to man, what is it? Hocus Pocus. Hocus Pocus, man. They got another one coming out. Alright, so anywho, we're converting here, doing standard dimensional analysis, right? So if you're converting grams to moles, we got to understand our units. Grams of hexane, right? So hexane here, and then we know that we're converting to moles of hexane. So this is always going to be the same every time. 1 mole of hexane, right? And then it gives us our molar mass, which is 86.8 grams of hexane, okay? So when we divide, right, 65.1 grams by 86.18 grams, right? So 65 divided by 86, that's going to give me 0.755. And this is in moles. So remember, this is moles of hexane. Now that we got that squared away, let's convert our other octane. So octane, we're looking at 60 grams of octane. You know, we got the oct. And then same thing here, 1 mole of oct. And the molar mass is given 114. So that's 114.2 grams. All right. And what is that going to be? So we're looking at 0.525, let me see, moles of my octane. Okay, oct. So now that I have both my moles here, what do we have to do from here? Okay, what do we have to do from here? So let's now use our equation to find our mole fraction. So we know with the mole fraction, we got the top portion, which is going to be my hexane, 0.755. And then on the bottom, we know it's going to be 0.755 because that's my hexane plus my 0.525, in this case, octane. Now from here, all we have to do is divide. So once we divide, we're going to see that we get our answer of 0.59, okay, as our final answer. All right, put the 0 just because everything's 3 suffix. But this is our final answer here. So you got that right. You are on the roll. You are on a roll. Here's your next question. All right, so we have 132 grams sample here of a non-volatile compound, and it's dissolved in 4.3 moles of cyclohexane, and we have the pressure for it too. The vapor pressure of the solution was determined to be 85. Okay, what's the molar mass of the compound? So we're trying to find the molar mass of the compound, and notice we're given a couple different things here. So we're given a mass of a sample, okay, and then it also tells us how many moles of our solvent we have with the pressure. And we also know that the vapor pressure of the solution was determined to be 85, okay? So we know the final vapor pressure of the solution. All right, so this is right, Raoult's law. We know that this is dealing with vapor pressure. We understand that dynamic equilibrium is taking place, right? If you don't remember, make sure to check my videos in the general chemistry playlist. Specifically, that's playlist number 2 when we're talking about general chemistry 2. We're looking at 85 for our solution here. Our vapor pressure of our solution. And I'm going to give you my units too. All right, so once again, it's pressure units. And then what I don't know in this case is, well, I don't know my solvent's mole fraction. So I don't know that. But I do know, right, my vapor pressure of my solution, which in this case, we understand is going to be 100, right? It's given to us. So now that I have this in place, right, I can now find my x. So in this case, your x that you're solving for is mole fraction. So my x, we're going to do some division here, and I'm going to get 0.85. Okay. So far, right, you figure out mole fraction. If you paused me before, you know, hopefully you've been able to do that. Okay. If not, it's okay. We're working it out. So now we got our mole fraction, 0.85. Now from here, right, if we have our mole fraction, what exactly is mole fraction? So mole fraction is when, right, you have your part, so whatever your numerator is, whatever you're solving for, over your total moles. So if we look at what's given, right, I have 4.3 moles of cyclohexane. And then I also know, what else? That I have 0.85 for my mole fraction. So because I know all these different things, right, let's solve for our mole fraction now. So we understand that we just determined, right, we have 0.85 for our mole fraction. So we already have our mole fraction in place, all right? And remember, mole fraction is this right here, right? In this case, you guys show whatever you want to solve for on the top. So if for instance, right, we're going to have our moles of solvent on top, and then we're going to have the total moles on bottom. And then, since we already know the mole fraction, it's already been found. But let's see how we can use this. All right, so like I said, in chemistry, you got to know algebra. You have to know algebra. So in this case, we have our 4.3 moles of our cyclohexane. Our mole fraction, we have our 4.3 moles of cyclohexane, right? Which in this case, we know is our solvent. Now, we want to determine, right, what is our total moles? What's the total moles? In this case of this solution, right? Because once again, everybody, we have this 132 gram sample, but it's asking for the molar mass of the compound. All right, so we really have to determine, right, what our total moles are right now. Okay, so let's look at our total moles. In this case, I'm just going to put X here. Now, doing some cross multiplication, bam, bam, we got to understand this is over 1. It's going to be 4.3. Cross multiply, bring those back over. 85. Okay. We do our math here, and we're going to get 5.05 for our total moles. Alright, so why was determining the total moles critical for us? Well, the reason being, right, is that we have to understand that, once again, we're looking for our solute in this case. So we know all our solvent stuff, but we're looking for our solute. And in this case, they want the molar mass. Okay, so because we know how much of our solute we have, but we're trying to figure out the molar mass of the solute. So the total moles, right, we need to understand that this is the total moles of my solute and my solvent. So in order to figure out our moles of our solute, we're going to subtract our total moles by our solvent moles, right, which in this case we know to be 4.3. Right, that's given. And then if we do 5.05 minus 4.3, we're going to get 0.7588 moles of our solute. So now we have our moles of our solute, and remind everybody, it's asking, right, for the molar mass of our compound, in which this case we know that we have 132 grams of our sample. So if I have 132 grams of my sample, and now I know the moles of my solute, right, which is the same sample, can we find molar mass? Yes, because molar mass is just grams over moles, right? Grams over moles. So I'm going to take my 132 grams. Once again, this is all unknown. And then we're going to take that moles that we just found here. And then I'm just going to divide 132 grams divided by 0.7588 is going to give me an answer of 173.9 grams, right, per mole. And we understand that this is molar mass, right? For every 1 gram equals, every 1 mole equals to a certain amount of grams. Okay, so this is the molar mass for our 132 gram compound there of our unknown. Woo! See, that was a lot of math, everybody. That was a lot of math, okay? Chemistry is math. I can't say that enough. You know, we had to do dimensional analysis in here, mole fraction, as well as a couple other different things, okay? Because the first thing you have to realize is that, well, you have to use Raoult's law, okay? If you did good on that one, great job. We're moving on to the next one. Okay, last question, everybody. All right, hopefully you guys are doing well. Once again, if you get all 3 right, you are a brave scholar. If you get 2 right, you are a never scared student. If you get 1 right, you're a courage, a calorie dog. And if you don't get any right, well, you know, it's okay. All right, so let's look at this last question. An aqueous solution of ethanol, which in this case, pay attention, the molar mass of ethanol is 46.07, has a molality of 12.15, right? Little m molality, and a density of 1.1 grams per milliliter. What's the molarity of ethanol in the solution? Okay, so you know the deal. Feel free to pause me. If not, let's start. Let's get to it. Let's go, go, go. Okay, so first thing that comes to mind, everybody, that you should definitely want to go through in your head. You know, what's the difference between molality and molarity? Okay, so if you don't know the difference, this is where you're going to get caught up. Okay, because it's asking for molarity, and then you're like, well, I thought molality was the same thing. No, it's not. Right? So molality is basically going to be moles over kilograms. All right, so the moles over kilograms equation. And then molarity, right, is going to be moles over your volume. So in this case, usually we're looking, in this case, we want the final answer to be moles over liters for molarity. So that's what we're looking for here, moles over liters. So now that we know our units, we can now try to do this problem here. So let's talk about molality, right? Because right now I got molality, I got molar mass, then I have density. How am I going to use these three different, right, numbers to help me out here to find the molarity of ethanol in the solution? Once again, not the molarity of just ethanol, but it's in the solution. So 12.15 little m. All right, little m. So we need to understand that, right, with molality, this is 12.15 moles of our ethanol. All right, ETH, right? Not ETH like, let me stop, ether. All right. So anywho, 12.15 moles of ethanol. And then we got 1 kilogram of our solvent here. Okay, so we're looking at molality right now. Now from here, right, we're going to do a couple of different things here. So, with this whole converting units, right, if I want to get, right, in this case, I can use this molality towards my benefit. If I just want to figure out my moles of ETH, because eventually, right, we have to understand that, well, I need to figure out a way to get to this moles over liters. Okay, and we're going to have to use moles in this case. Now, what we can do here, let me just multiply my 1 gram of solvent by another 1 gram of solvent. And what happens to the units? They cancel out. Guys, this is dimensional analysis. Dimensional analysis at its finest. So once you get those canceled, now you're in moles of your ethanol here. And then what can we do from here? Well, I can actually convert this to grams. Because I have my molar mass. 46.07 grams of ethanol. Now, once I multiply and do my thing here, I'm going to see that I get 559.8 grams of ethanol. All right. So that's how many grams of ethanol I have so far. Now, you're probably wondering, well, why is this? Why did you convert to grams? What am I going to do with grams now? Right. Let's talk about it. So now that I have the grams of ethanol, what else do I have? Right? Because it's asking for the ethanol in solution. So in this case, I need to figure out, well, what's my total mass of my solution anyway? Right? Because it's asking for the ethanol in solution. I don't even know the total mass yet. Now, if I just determine my mass of ethanol here, and we understand with molality that we have 1 kilogram of our solvent, right? 1 kilogram of our solvent. So that means that if I add my ethanol and my solvent together, that will give me my mass of solution, right? So basically, if I add 559.8 grams of ethanol plus 1 kilogram of solvent, or you could just say 1,000 grams, right? Because for every 1 kilogram, we have 1,000 grams, right? With prefixes. And then this is our solvent. We add both those together, we get 1559. Oh boy, y'all see that? 0.8 grams, right? And this is my solution. So now, right, I know the mass of my total solution. Now, you're probably wondering, well, why did you calculate the mass of the solution, right? Why are we doing all this work? The reason why I have the mass of solution is because they gave me density. They gave me the density, all right? They gave me the density. Density of the entire solution at 1.1 grams per milliliter. So, because I know the density, with density, we understand that this is a derived unit, grams per milliliter. So, converting, right, I could potentially convert my grams to milliliters, right? If you're following me, say that you're following. If you're not, let me know in the comments, please. Let me know in the comments. All right, so we got the 1559.8 grams of our solution. And we understand, right, that because they gave me the density is 1.1 grams per milliliter. Okay. Notice that our grams will cancel out here, leaving me with my milliliters on top. And what are we noticing right now, everybody? What are we noticing? So if I just converted my mass of solution to milliliters, all right, and I understand that they want molarity, I might as well just convert this to liters, because we understand that molarity is moles over liters. So for every 1 liter, we got 1,000 milliliters. All right, I'm going to do my math here. Right, top 1559 times 1,1, that's my top number. Divide that by my bottom number, 1.1 times 1,000. That's going to give me 1.48 liters of solution. So now I got my solution, right? So if I got liters of solution, right, and they're asking me for molarity, let's think about molarity, right? Molarity is moles over liters, moles over liters. So if I set this up, let me see what I have so far. Molarity, that's what we're looking for. Finally I got my liters. Okay, but what about the moles? What about the moles of my solute? Right, because that's what molarity is, moles of solute. In this case, a solute is ethanol. Do we have the moles of solute? Yes. Yes, we do, in fact. The moles of solute was given to us because we understand that molarity and molality both have moles. Y'all, they both have moles. With molality, we got the moles of our ethanol over our kilogram of solvent. Molarity is just the moles of the solute over the volume of the solution. So we already know the moles. It's 12.15. So now, right, with our molarity, we know the moles. We got the volume now. All we have to do is divide. And once we divide, I'm going to see that I have an 8.5 molar, all right, solution here. All right, so this is the molarity of my ethanol in this solution. All right, like I said, y'all, it's a lot of math going on here. A lot of math. We had to realize that we had to, first off, determine what's the difference between molality and molarity. Molality is going to be moles over kilograms. Molarity is moles over liters, right? Then from here, we had to realize that, well, we could just convert some stuff. I could get rid of this kilograms of solvent by converting it, right, multiplying it with 1 kilogram of solvent. And then I could convert my moles to grams using my molar mass. And then from here, right, I can add up my solute and solvent together to have my mass of solution, to where then I can convert my mass of solution to my volume of my solution using density. All right. And then once I have the liters of solution, we just got to plug it into our molarity equation now, right? Because we know the liters of solution, and then we already know the moles of the solute. Moles over liters, that's molarity, 8.5 molar. Okay. So this one is a lot of just figuring out, right? That's the crazy thing about chemistry. If you know how to do math, you know, you can definitely get by with some of these conversion factors. And like I said, dimensional analysis is never going away, everybody. So please review that. How'd you do? Did you get 1 right? Did you get 2 right? Did you get 3 right? Let me know in the comments, and I will see you next time on What Do You Know? What do you know? What do you know?